close your eyes and imagine a world where the sky is not a color, but a profound and haunting absence. For some, the vast expanse of the atmosphere is a silent void, a mystery that the eyes simply cannot decode. Why is it that for millions of humans, the color blue is a vivid staple of reality, while for others, it remains a ghost, an invisible frequency dancing just beyond the reach of their perception? Tonight, we begin a journey into the biological gatekeepers of our own eyes, unraveling the secrets of how we see, and why some of those secrets remain locked away. If you find peace in these nightly journeys into the unknown, please consider subscribing to our channel to join us every night as we explore the mysteries of our world. To understand this mystery, we must travel back to the very dawn of our species, to a time when our ancestors lived in a world of shadows and flickering firelight. In those primitive days, the human eye did not need to distinguish between a ripe berry and a poisonous leaf or a hidden predator in the brush. It only needed to know if light was present at all. This was the era of primitive light detection, where our ancestors relied on a single type of photoreceptor. They lived in a world of monochrome, a grayscale existence where the nuance of a sunset was lost to the simplicity of shadow. But evolution is a patient architect. As our ancestors moved into more complex environments, the pressure to survive demanded more. We began the transition toward trichromatic vision, a biological revolution that allowed our eyes to split the incoming light into 3 distinct channels. This change was not just a visual upgrade, it was a fundamental shift in how we interacted with the planet. It allowed us to see the world in 3 primary dimensions of light, giving us the ability to perceive the vibrant diversity of the natural world. Deep within the retina, this process begins with a dance of chemistry. Imagine tiny, specialized cells called photoreceptors, waiting in the dark. When a photon of light strikes the eye, it triggers a chemical reaction involving a protein called rhodopsin. This protein is the sentinel of the night, capturing light and converting it into an electrical pulse. Within the retina, 2 main players perform this duty. There are the rods, which are incredibly sensitive and allow us to navigate the dim twilight, and the cones, which are the artists of the visual world. The cones are responsible for the richness of color. Most humans possess 3 types of cones, each tuned to a different wavelength. However, here is where the mystery deepens. For some, the biological blueprints are slightly different. The S cones, the specific gatekeepers of the short, high-frequency wavelengths, may fail to fire or may be tuned differently. When these gates do not open, the blue frequency remains a phantom. It is a frequency that exists in the physical world, but for the individual, it is a secret the brain cannot translate. We are standing at the threshold of the invisible, where the biology of the eye meets the mystery of the missing blue. But what if the very concept of a color was a luxury our ancestors simply did not possess? To understand how early civilizations categorized the unreachable hues, we must first step back into a time before the birth of language, back when the human experience was defined not by names, but by feelings. For the prehistoric tribes of our distant past, the world was not a gallery of distinct pigments, but a tapestry of sensory impressions. They did not see blue as a primary category. They felt the coolness of a shadow, the depth of a lake, and the vastness of the horizon as unified experiences of atmosphere. In these early epochs, the human eye was a tool for survival, and survival demanded a different kind of classification. Our ancestors lived in a state of sensory grouping, where colors were tied inextricably to their environmental utility. When a hunter looked at a cluster of berries or the vein of a mineral in a rock, they were not identifying a hue on a spectrum. They were identifying a source. They saw the fruit-like or the stone-like. The transition from feeling a sensation to naming a color was a monumental leap in human cognition. It required the brain to detach a visual experience from its physical object and give it a standalone identity. However, for the blue end of the spectrum, this transition was uniquely difficult. Because the sky and the ocean are so vast and lack tangible boundaries, they were often relegated to the realm of the unreachable. In many early tribal cultures, the cool tones of the world were grouped together into a single, massive category of coolness or distance. They were colors of the void, of the things that cannot be held in the hand. While a red berry could be grasped and a green leaf could be eaten, the blue of the atmosphere was a ghost that could only be felt as a change in temperature or a shift in the quality of the air. Our primitive ocular anatomy played a significant role in this sensory grouping. Because the escones were less dominant in the ancestral environment, the brain had to work harder to distinguish the subtle shifts in the shortwave spectrum. This resulted in a visual world where the atmosphere was often perceived as a neutral, looming presence rather than a specific tint. Weather patterns further complicated this identification. A heavy fog or a clear, high-altitude sun would fundamentally alter the visual input, causing early humans to define their world by the clarity of the air rather than the specific wavelength of the light passing through it. Eventually, this led to the birth of the first subjective color descriptors. Before there were words for cyan or azure, there were descriptions of the breath of the wind or the depth of the water. These were the first linguistic anchors for the unreachable. They were not names for colors, but poetic echoes of a sensation that the eye could sense, but the mind could not yet isolate. We see the history of the human eye not just as a biological progression, but as a slow, deliberate awakening of the mind, trying to carve out names for the invisible ghosts of the spectrum. But what if the very reason we struggle to define the blue of the heavens is because, for most of our history, that color simply did not exist in the physical world we could touch? To understand why blue was the rarest pigment in the ancient world, we must look past the sky and into the very earth beneath our feet. In the early eras of human civilization, the world was painted in earthy tones. The mountains were ochre, the soil was sienna, and the forests were 1,000 shades of green and brown. These were colors of the ground, colors that could be crushed into dust and mixed with oil or water. Blue, however, was a fugitive of the atmosphere, a color that lived in the air but refused to stay on the page. Geologically, the world is not painted evenly. While minerals like iron oxide are abundant, providing the reds and yellows that dominated early human art, blue minerals are notoriously elusive. For thousands of years, the hunt for blue was a hunt for the rare and the distant. The most famous of these was lapis lazuli, a deep, celestial stone that could produce a vibrant ultramarine. Yet, this stone was not common. It was found in specific, isolated veins, primarily in the mountains of what is now Afghanistan. To possess a single gram of this pigment was to possess a geological miracle. It was a color that required a journey of thousands of miles, crossing treacherous deserts and mountain passes, just to be brought into the light of a human workshop. Even when humans attempted to find blue in the flora of our world, they were met with chemical defiance. While plants offer an abundance of reds and yellows through berries and flowers, blue is a rare biological trait in the plant kingdom. Many of the blues we see in nature today are not true pigments, but are structural colors, created by the way light bounces off microscopic structures. For an ancient chemist, trying to extract a stable blue dye from a leaf was a frustrating, often impossible task. Organic dyes for blue were notoriously unstable. They would fade, shift, and decay, making them useless for the enduring permanence required by religious icons or royal garments. This scarcity created a profound hierarchy of value. Because blue was so difficult to mine and even harder to stabilize, it became a color of the elite. In the ancient world, to wear blue or to paint a figure in blue was to signal a command over the earth's rarest treasures. It was a color of power because it was a color of extreme logistics. The trade routes required to move these pigments were some of the most sophisticated of the ancient world, weaving together empires just to supply a single hue. When we look at the history of human art, the absence of blue is not a lack of imagination. but a reflection of a physical world where the blue of the sky was a ghost, and the blue of the earth was a miracle. And yet, while we marvel at the rarity of blue pigments on our hands, we often overlook the invisible architect that sculpted our very ability to see it, the atmosphere itself. To understand why our ancestors' eyes were tuned the way they are today, we must look upward, into the swirling gases of our world, and consider the profound physics of the sky. Imagine the Earth's atmosphere as a vast, shimmering filter, a lens through which all light must pass before it ever reaches the retina. This filter is composed primarily of nitrogen and oxygen molecules. When sunlight strikes these molecules, a phenomenon occurs known as Rayleigh scattering. Because shorter wavelengths of light, the blues and violets, are more easily deflected by these tiny gas particles than the longer, lazier wavelengths of red and yellow, the very air around us acts as a prism. It scatters the blue light in every direction, creating that vast, immersive dome of color we see above us. For our ancestors, this was not just a visual backdrop, it was an evolutionary crucible. In the dawn of human history, our eyes were being shaped by this constant atmospheric filter. Evolution is a process of optimization, and the human eye had to adapt to a world where the sky was a pervasive, blue-tinted veil. This wasn't just a matter of aesthetics. The atmosphere served as a biological shield, filtering out the harsh, high-energy ultraviolet rays that could damage delicate tissues and DNA. Our ancestors' eyes were essentially tuned to this specific atmospheric frequency, learning to navigate a world where blue was the dominant, diffused signal of the horizon. But why did we retain the ability to perceive this specific frequency? The answer lies in the primal needs of survival. In the wild, the ability to distinguish blue was a matter of life and death. Blue was the primary indicator of water, the most precious of resources. It was the color of the oasis, the hidden spring, and the life-giving river. To see blue was to see hydration. Furthermore, the blue spectrum allowed our ancestors to identify specific food sources and navigate deep-water environments where the refraction of light changed. Our eyes evolved to pick out the blue of a distant lake against the brown of the desert, a visual shortcut to survival. By refining our vision to detect these short wavelengths, our ancestors unlocked a secret of the natural world. They were not just seeing a color, they were reading a map of resources. Their eyes became finely calibrated instruments, capable of decoding the atmosphere's scattered light to find water and nourishment. We are the descendants of those who could see through the veil of the air. Our visual systems, still vibrating with the echoes of an ancient evolutionary requirement to find life in the blue. And yet, while our ancestors evolved the biological tools to detect the blue of a distant oasis, they faced a strange linguistic paradox. How do you describe a color that feels like a ghost, a hue that exists everywhere yet belongs to nothing? To understand how early poets described colors they could not name, we must step into a world where the vocabulary of the spirit was forced to bridge the gap left by a lack of visual labels. In many ancient civilizations, the word for blue was absent from the daily vernacular, creating a profound linguistic void where the eye saw a sensation but the tongue found no name. Because they lacked a direct noun for the hue, early poets were forced to become masters of metaphor. They did not describe the sky as blue, they described it as sky-like. They spoke of the color of the distance, or the shade of the infinite. This was not a failure of imagination, but a sophisticated way of coding a sensory experience that felt too vast to be contained by a single word. When a poet spoke of the breath of the heavens, they were attempting to translate a visual frequency into a spiritual feeling. They were describing the quality of the light, its coolness, its depth, its ability to recede, rather than its position on a chromatic scale. In these early literary traditions, blue was often blended with the colors of shadow and gray. Because the human brain struggles to isolate a color that is constantly shifting, poets described the atmosphere as a veiled or shadowed expanse. They lived in a world of tonal transitions, where the blue of a lake was often synonymous with the darkness of the deep. By tethering the unnameable hue to the concepts of shadow and depth, they gave the color a weight and a gravity that a simple label could never provide. They were capturing the mood of the color, the melancholy of a twilight sky or the heavy silence of a mountain mist, rather than the literal pigment. This poetic frustration reveals a fascinating truth about human perception. Our emotions often precede our definitions. The unnameable hue was a source of sublime mystery, a color that evoked a sense of yearning because it could not be grasped by the mind. It was the color of the unreachable, and by leaving it unnamed, the poets allowed it to remain sacred. They understood that to name a thing is to domesticate it, and by refusing to give the blue of the horizon a name, they preserved its power as a symbol of the divine. As these cultures traded and collided, we see the fascinating translation of colors across different tongues. One culture's spirituado became another's heavenly breath. These were not just different words, they were different ways of perceiving the same elusive frequency. Eventually, we see the slow evolution of the word azure. It began not as a mere description of a pigment, but as a spiritual descriptor. It was the color of the celestial, a word that carried the weight of the heavens. It was the linguistic bridge that finally allowed humanity to step across the gap, turning a haunting absence into a named reality, and turning a phantom of the eye into a cornerstone of our shared world. But if we have spent millennia naming the blue of the heavens, why does the human brain still treat it as a distant, almost secondary phantom compared to the vivid urgency of red and green? To solve this, we must descend beneath the surface of the eye and into the complex architecture of the visual cortex, where the brain performs a constant, frantic act of triage. You see, the brain does not treat every wavelength of light with equal importance. It operates on a strict neurological hierarchy designed by millions of years of survival. When light enters the eye, it travels along the optic nerve, a high-speed data cable carrying millions of electrical impulses toward the back of the brain. Here, the visual cortex must decide what information is vital and what can be ignored. This is where the mystery of loud wavelengths begins. In the evolutionary theater of our ancestors, certain colors were literally louder. Red and green were the frequencies of life and death. Red was the warning of a predator, the ripeness of a fruit, or the flush of blood. Green was the dense thicket of a forest or the lushness of a food source. Because these colors provided immediate, actionable data, the brain wired itself to prioritize their processing. They are the high-priority alerts of the visual system, demanding faster neural pathways and more immediate recognition. In contrast, the blue spectrum occupies a different space in our mental map. Because blue is less frequent in the immediate, tactile world of our ancestors, the brain evolved to treat it as a recessive color. In the visual cortex, blue often feels distant because it is the color of the horizon, the deep water, and the vast sky, things that are physically far away. Our brains have learned to associate these wavelengths with distance, effectively pushing them into the background of our conscious perception. While red screams for attention, blue whispers from the periphery. Furthermore, the brain utilizes a process of frequency suppression. To prevent sensory overload, the visual cortex filters out certain frequencies that provide less survival value. For many, the subtle nuances of blue are muted because they don't provide the same immediate contrast against a background as the warm tones do. This is why, in your mental imagery, a red apple feels heavy and present, while a blue mountain feels light and recessive. It is a biological shortcut. The brain is essentially saying that while the blue of the sky is beautiful, it is not an immediate threat or a meal. This hierarchy of importance explains why some people find blue so elusive. If the neural pathways for shortwave detection are less robust, the brain may struggle to pull that information forward into the foreground of consciousness. For these individuals, The blue frequency is like a radio station that is constantly playing in the background of their lives, but the volume is turned so low that it barely registers against the loud, vibrant broadcast of the rest of the world. We are not just seeing with our eyes. We are filtering reality through a prehistoric hierarchy of importance, where the ghosts of our ancestors' needs still dictate which colors we see and which ones we let fade into the shadows of the mind. Imagine a world where the very sky above your head was not a color, but a philosophical paradox. For the ancient Greeks, the concept of what we now call cyan was not merely a matter of optics, but a profound mystery of the human soul and the limits of perception. To understand their world, we must step back into a time when the line between the physical object and the mental experience was blurred into a haze of debate. In the bustling agora and the quiet gardens of Athens, philosophers began to wrestle with a fundamental question. Was a color a thing that exists in the world, like a stone or a tree, or was it merely a ghost created within the mind? When they looked at the shimmering, pale turquoise of the Aegean Sea, they struggled to decide if that blue-green hue lived in the water itself, or if it was a private hallucination born in the spark of the human eye. The Greeks faced a linguistic hurdle that shaped their very reality. In many early dialects, there was no specific word for the delicate spectrum of cyan. It was a hue that hovered in the shadows of language, often subsumed by broader terms for the sea or the heavens. Because they lacked a specific name, the color became an elusive target of the intellect. It was a color that existed in the periphery, something felt but not fully captured by the tongue. This lack of a specific name led to a fascinating spiritual association. Because the sky and the deep sea were so vast and ungraspable, the Greeks began to view these blue-green shades as the domain of the divine. They saw these colors as the veil between the mortal world and the infinite. To them, the horizon was not just a geographical line, it was a philosophical unreachability. It was the point where the known world dissolved into the unknown. When they gazed at the distant, hazy blue of the coast, they were looking at the edge of human knowledge. The Greeks explored the mechanics of light and shadow not through modern physics, but through the lens of appearance. They theorized that light was a medium of clarity, while shadow was the absence of truth. In this framework, the transition from a deep, heavy blue to a light, ethereal cyan was seen as a movement toward the spiritual. It was a transition from the heavy matter of the earth to the weightless ether of the gods. They moved from simple observation to abstract thought, wondering if the human eye was a perfect mirror of nature or a flawed interpreter. They realized that the brain does not just see, it interprets. By contemplating the unreachable hues of the horizon, the Greeks were actually exploring the boundaries of the human psyche. They were asking if we ever truly see the world as it is, or if we are forever trapped inside the beautiful, colored theater of our own minds. In the silence of their meditations, the color cyan became more than a pigment. It became a mystery of the infinite. But if the Greeks were wrestling with the philosophy of the sky, the ancient Egyptians were facing a much more physical, and perhaps more desperate, struggle to capture it. Imagine standing in a sun-drenched workshop in the Nile Valley thousands of years ago, surrounded by the heavy scents of crushed minerals and heated resins. Here, the quest was not just to understand the blue, but to manufacture it, to take the infinite expanse of the heavens and trap it within a jar of pigment. For the Egyptian artisan, the sky was not a mere aesthetic choice. It was a theological imperative. The heavens were the realm of the gods, and to represent the divine, one had to find a way to manifest the color of the infinite. Yet, they were met with a profound technical wall. In the ancient world, blue was not a color that lived in the earth. It was a color that had to be forged. The artisans faced a frustrating chemical failure. They experimented with copper-based dyes, attempting to coax a vibrant azure from the minerals available to them. But early copper pigments were notoriously fickle. They would often turn a sickly, dull green or tarnish into a muddy brown when exposed to the air. To the Egyptian eye, These failures were more than just chemical errors. They were spiritual disappointments. They were trying to paint the throne of the gods, and the earth was refusing to give up its secrets. Because the true blue of the atmosphere remained chemically elusive, the Egyptians were forced into a beautiful, desperate compromise. They turned their gaze toward the river that sustained their civilization. They looked at the shimmering, life-giving waters of the Nile and the vibrant stones found in the desert. They mastered the art of turquoise. Turquoise became the surrogate for the sky. It was a brilliant, sea-green hue that sat on the edge of blue, a color that felt heavy with the presence of water and life. By using turquoise, the artisans created a bridge between the terrestrial and the celestial. When you see an ancient Egyptian wall painted in these shades, you are looking at a deliberate artistic shorthand. They knew they could not perfectly replicate the exact frequency of the overhead blue, so they chose a color that represented the idea of the blue, the majesty of the Nile and the spiritual depth of the heavens combined into a single, workable pigment. It was a mastery of substitution. They understood that the human mind would accept a symbol if the truth was unreachable. The blue of the pyramids and the tombs was a victory of the imagination over the limitations of chemistry. It was a way of saying that even if the artisan's hand could not grasp the exact hue of the sun's path, the spirit could still reach for the infinite. In every stroke of turquoise, there was a hidden confession of human limitation, a quiet acknowledgement that the true blue of the sky remained a mystery that the world of men was not yet permitted to own. Yet, while the Egyptians settled for the substitute of turquoise, a far more secretive and arduous journey was unfolding across the vast, rugged landscapes of the East, where a different kind of blue was waiting to be forged. To understand the true blue of the ancient world, we must travel to the high, desolate mountains of modern-day Afghanistan, to the legendary mines of Badakhshan. Here, deep within the earth, lies the source of lapis lazuli, a stone so prized that its journey from a raw rock to a royal pigment was shrouded in layers of mystery and extreme peril. For centuries, the extraction of this stone was a feat of grueling physical endurance. Miners would delve into treacherous crevices, hauling heavy chunks of deep blue rock from the mountain's heart. But the stone in its raw state was not the vibrant azure we recognize today. It was a messy, complex mixture of minerals, containing impurities of calcite and pyrite that would dull its brilliance. The secret of the color did not lie in the mining alone. It lay in the painstaking, almost ritualistic process of purification. To transform this dull rock into the legendary pigment known as ultramarine, the stone had to undergo a transformative metamorphosis. It was crushed into a fine powder and mixed with heated wax, resins, and oils. This mixture was kneaded into a paste and submerged in a bath of boiling water or vinegar. Through this arduous cycle of heating and cooling, the blue particles would slowly separate from the impurities, migrating into the liquid while the gray waste stayed behind. This was the birth of ultramarine, the most expensive and coveted pigment in human history. Because of this grueling production, the cost of the color was astronomical. In the medieval world, ultramarine was often more expensive than gold. It was a luxury so profound that its use was dictated by the highest tiers of power. To own a piece of this blue was to possess a fragment of the divine. This high cost birthed a culture of extreme secrecy. The production of the pigment was guarded by the clandestine guilds of dyers and painters, men who held the chemical secrets of the stone like state secrets. To share the technique of purification was to risk ruin, as the value of the color relied entirely on its scarcity. Beyond its material cost, the stone carried a heavy weight of spiritual protection. Ancient travelers and scholars believed that lapis lazuli possessed a mystical energy, a shield against the malevolent forces of the unknown. It was thought to be a stone of truth, capable of opening the third eye and revealing the hidden dimensions of the universe. When a painter applied ultramarine to the robes of a saint or the crown of a queen, they were not just applying paint. They were layering the canvas with a substance that had traveled across mountains, survived the fires of purification, and carried the weight of both sacred mystery and royal authority. It was the ultimate alchemy, turning a piece of the earth into the very color of the heavens. But as we move from the rugged mines of the East into the hallowed cathedrals of the West, we find that the scarcity of blue did not merely dictate what people could afford to see, but fundamentally reshaped how they chose to represent the holy. In the heart of the Middle Ages, the lack of accessible blue pigments created a profound visual crisis for the artists of the era. They were tasked with depicting the divine, yet they were working with a palette that was often incomplete. To navigate this, they developed a sophisticated language of visual substitution, where the absence of a color became a deliberate theological statement. Because true ultramarine was a luxury that could bankrupt a parish, the most common way to depict the heavens was not through a blue pigment at all, but through the radiance of gold leaf. In the flickering candlelight of a stone chapel, gold was the ultimate proxy for the infinite. When an artist could not afford the blue of the sky, they used the brilliance of gold to represent divinity. The gold did not just reflect light. It was intended to suggest a light that came from within the image itself, a spiritual glow that transcended the physical limitations of the paint. It was a way of saying that the divine was too bright to be captured by a simple hue, and therefore, it had to be rendered in the most precious of metals. When gold was unavailable or insufficient, the artists turned to a different kind of compromise, reaching for the deep, heavy tones of violet and purple. In a world where blue was a rare treasure, violet became the shadow of the heavens. These deep, bruised hues were used to bridge the gap between the earthly and the celestial, providing a sense of weight and solemnity that a lighter blue could not achieve. By choosing these darker tones, the painters were able to create a sense of mystery, a visual depth that suggested a realm hidden just behind the veil of the visible world. This scarcity extended beyond the canvas and into the very fabric of the clothing worn by the people. In the medieval social hierarchy, blue cloth was a marker of immense status. Because the mordant dyeing process, the chemical binding of dye to fiber, was so limited and difficult to master for blue hues, the color became a literal badge of wealth. To wear a blue mantle was to announce that you possessed the resources to command the rarest of pigments. This interplay of status and spirituality culminated in the iconography of the Virgin Mary. Her mantle, traditionally depicted as blue, served as the primary vessel for this visual tension. When she was painted in blue, it was a display of ultimate devotion, a sacrifice of wealth to honor her status as the Queen of Heaven. In pieces where blue was missing, the void left by the absent pigment forced the viewer's eye to wander, creating a psychological space where the imagination had to fill in the holiness. These visual voids were not seen as flaws. They were the silence between the notes of a spiritual melody, a way of acknowledging that some truths are too vast to be fully painted by human hands. Yet, beyond the physical scarcity of pigments and the artistic compromises of the Middle Ages, a far more profound and invisible barrier existed in the very architecture of human thought. To understand why blue was so often omitted from early linguistic structures, we must peel back the layers of how the human brain actually constructs the concept of a color. For much of our ancestral history, the human mind did not perceive the world as a kaleidoscope of distinct hues, but rather as a landscape of functional categories. This phenomenon is explored through the Berlinke theory of color naming, a groundbreaking linguistic observation which suggests that color perception is not just a biological fact, but a cultural construction. According to this theory, as cultures develop their linguistic structures, they tend to name colors in a predictable, evolutionary sequence. Most cultures begin by distinguishing between dark and light, then black and white, followed by red. Interestingly, blue is almost always the last color to receive its own independent name. In many early societies, the human brain did not see blue as a primary category of existence. Instead, it was a cognitive outlier that required a significant mental leap to isolate. In these early linguistic structures, blue was often not a standalone concept, but was instead grouped with other colors that shared similar psychological weight. In many ancient tongues, the words for blue and green were interchangeable, creating a unified category of cool colors. This is why, in many early civilizations, the distinction between the lush growth of a forest and the vast expanse of the ocean was not a matter of color, but a matter of utility. To the ancestral mind, these were both shades of life-giving moisture. Similarly, in some cultures, blue was subsumed into the category of black. When the sky turned a deep, midnight hue, it was not seen as blue, but as the absence of light, a transition into the void. This lack of a distinct word for blue meant that the distinction between the sky and the ocean often vanished in the spoken word. In some languages, a single term described both the overhead atmosphere and the deep water. This suggests that for these people, the blue was not a property of the object, but a shared quality of the infinite. They did not see two different things. They saw two different manifestations of the same unreachable horizon. Archaeological evidence of these linguistic gaps is hidden in the very artifacts we uncover today. We find pottery and textiles where the intention was clearly to represent the heavens, yet the vocabulary of the people who made them lacked the precision to name the specific frequency of the light. They were navigating a world where the brain recognized the hue, but the language had not yet caught up to provide it a home. It was a period of sensory transition, where humanity was slowly learning to carve out a specific space for the blue, moving it from a ghost in the periphery of the mind into a defined word in the treasury of the human voice. But if the human voice had not yet found the words to name the blue, how did our ancestors attempt to capture it through the medium of the sacred? Beyond the limits of language and the scarcity of minerals, there existed a world where the color blue was treated not as a visual fact, but as a spiritual entity that had to be summoned, appeased, and tethered to the physical realm through elaborate androgynous rituals. In many ancient traditions, the act of producing blue dye was far more than a chemical process. It was a ritual of extraction. To those who lived before the age of industrial chemistry, the transition of a fiber from its natural state to a vibrant blue was seen as a mystical metamorphosis. Dyers would work in seclusion, performing rhythmic movements and repetitive chants to coax the color out of organic matter. They believed that they were not merely applying a substance, but were performing a spiritual purification. By staining a garment blue, they were believed to be washing away the mundane and clothing the wearer in a layer of celestial protection. The dye was a bridge, a way to clothe the human body in the frequency of the divine. This belief in blue as a gateway extended into the very geography of the afterlife. In various cultures, the deep, ungraspable blue of the horizon was viewed as the literal threshold where the world of the living ended and the realm of the spirits began. To cross into this blue space, one required offerings. In certain coastal and riverine civilizations, rituals were performed to water deities, where blue-stained objects were cast into the depths. These were not merely discarded items. They were sacrifices made to ensure that the passage between worlds remained open. By offering the color of the water back to the water, they sought to maintain the balance of the horizon. In the secretive chambers of early alchemy, the summoning of blue became a pursuit of the soul. Alchemists viewed the quest for the perfect azure as a microcosm of the great work. They sought to bleed the blue from the sky, attempting to condense the vastness of the atmosphere into a single, stable drop of liquid. They believed that by capturing the essence of the heavens, they could unlock the secrets of immortality. They worked with heavy metals and volatile spirits, trying to force the universe to yield its most elusive frequency. There were even myths of bleeding the sky, tales of sorcerers who could reach into the clouds and pull down threads of blue to weave into shrouds for the dead. While these stories were often metaphorical, they speak to a profound psychological truth. Because the blue of the sky was so vast and unreachable, humanity felt a desperate need to capture it. They turned the color into a mystery that required a ceremony to solve. They moved from seeing a color to performing a rite, transforming a simple wavelength of light into a holy invocation, a ritualistic plea to bring the infinite into the palm of a human hand. Imagine walking through a world where the very colors you see are treated not as a biological fact, but as a symptom of a fractured mind. To understand how we arrived at our modern understanding of the eye, we must travel back to a time when the boundary between the physical world and the internal psyche was blurred by shadow and superstition. In the 17th century, the medical world operated in a landscape devoid of neurological tools. There were no scans to peer into the brain, no chemical tests to map the retina, and no genetic markers to explain why one person might see a vibrant sapphire while another saw only a dull gray. When a patient described a visual experience that deviated from the norm, the physician did not look for a faulty cone cell or a genetic mutation. Instead, they looked for a failing spirit or a corrupted humor. During this era, the prevailing theory of medicine was rooted in the four humors. It was believed that the balance of blood, phlegm, black bile, and yellow bile dictated every aspect of human health. If a person reported seeing strange sights or perceived colors differently than their peers, it was often attributed to an imbalance of these fluids. A strange sight was rarely treated as a sensory deficiency. Instead, it was categorized as a hallucination, a byproduct of an overflowing imagination or a wandering mind. Consider the plight of a person who could not perceive the specific wavelength of blue. In a world where blue was already a rare and mysterious concept, a person who saw only a muted, muddy hue might be told they were experiencing a form of hysteria. Hysteria was a broad, catch-all diagnosis for any behavior or perception that seemed irrational. If your eyes did not mirror the consensus of the crowd, it was assumed your mind was betraying you. The subjective reports of these patients were often dismissed as symptoms of a melancholic state of mind. They were told they were seeing ghosts or dancing shadows because their humors were out of alignment, rather than being told that their eyes simply lack the machinery to process a specific part of the light spectrum. This was a period of profound transition, where the medical community was slowly moving from spiritual to biological diagnoses. It was a journey from the why of the soul to the how of the body. For centuries, the inability to see a color was a spiritual failing or a mental lapse. It was only as we began to dismantle the myths of the humors and look toward the physical architecture of the eye that we realized something profound. The madness wasn't in the mind of the observer, but in the limitations of our previous understanding. We were looking at a biological miracle and calling it a psychological tragedy, mistaking a quiet difference in wiring for a loud cry of insanity. But what if the very first person to suffer from this hidden sensory void lived in a world that had no name for their condition? To find the first recorded instance of tritanopia, we must peel back the layers of medical history to a time when the human eye was viewed as a mystical portal rather than a complex optical instrument. For centuries, the inability to distinguish between blue and yellow was not a medical condition. It was a ghost story. Because the blue frequency is so specific, those who could not perceive it were often grouped into a broad, undifferentiated category of dim-sightedness or failing vision. In the early clinical records, the distinction between the two primary types of color blindness was almost non-existent. We now know that protanopia affects the perception of red light, while tritanopia specifically targets the short wavelengths of the blue spectrum. However, the early physicians who documented these cases lacked the technology to differentiate between the two. They saw a patient who struggled to navigate a vibrant world and simply recorded a general deficiency of color. It was a period of profound confusion where sensory deficits were frequently mistaken for neurological decay or even degenerative diseases of the optic nerve. The true journey toward identifying tritanopia began when scientists started to move away from subjective reports and toward objective observation. They began to notice that some individuals did not see a different color, but rather a missing one. They observed a peculiar phenomenon where certain patients would describe a world that felt strangely muted, as if a specific note in a symphony had been permanently silenced. These were the first whispers of the blue-yellow color blindness. It was a gradual realization that the brain was receiving data from the eye, but the eye was failing to capture a specific slice of the electromagnetic spectrum. Early attempts to test this perception were rudimentary and often led to baffling results. Researchers would present subjects with various pigments, and the frustration of the observers grew when a patient would insist that two distinct hues were identical. This led to a period of intense scrutiny where doctors tried to determine if the missing blue was a result of the lens being clouded, the retina being scarred, or the brain simply being unable to interpret the signal. They were hunting for a phantom in the machine. The mystery deepened because, unlike red-green color blindness, which is far more common and easier to detect in everyday life, tritanopia is a rare and subtle thief of the visual experience. It was a hidden anomaly, a secret held by a small minority of the population. It took years of careful, painstaking observation to move past the myth of dim sight and recognize that the human eye could truly be blind to a specific frequency of light. We were beginning to understand that the spectrum was not a shared human experience, but a variable one, where some souls were born into a world where the blue horizon was forever veiled in a veil of yellow-tinted shadow. But what if the very architecture of our reality was not just a biological miracle, but a masterpiece of chemical engineering? As we moved away from the mystical interpretations of the eye and into the tangible world of the Industrial Revolution, the human visual landscape underwent a transformation so profound that it fundamentally altered how our species perceives the presence of color. Before the steam engine and the factory, the world was painted in the hues of the earth. If you wanted blue, you had to mine it, crush it, and refine it from rare minerals or precious stones. Color was a luxury of the elite, a slow and arduous process that kept the majority of the human experience draped in the muted tones of organic matter. Then came the great upheaval of the industrial era, where synthetic chemistry began to dismantle the monopoly of nature. The invention of synthetic dyes in the 19th century was not merely a technological advancement, it was a sensory revolution. For the first time in history, humans learned how to manufacture color from the bottom of a beaker rather than the heart of a mountain. Chemists discovered they could synthesize vibrant, stable pigments that did not exist in the wild, effectively creating a new palette for the human eye to consume. This transition from organic to chemical blue signaled a shift in our collective consciousness. Blue was no longer a rare gift of the atmosphere or the sea. It became a commodity, a mass-produced standard that could be poured into vats and distributed across continents. This democratization of color changed the very fabric of our daily lives. As synthetic dyes became cheaper and more accessible, the visual landscape of the home began to shift. Walls, textiles, and everyday objects were suddenly flooded with standardized hues that had never existed in such intensity before. We moved into a world of saturated uniformity, where the standard blue was no longer a unique geological find, but a consistent chemical output. This era gave birth to the modern visual standard, where we expect a certain shade of blue to look the same in a shop in London as it does in a factory in New York. However, this explosion of color brought with it a new kind of visual pollution. The industrial era replaced the subtle, varied gradients of the natural world with a harsh, uniform intensity. Our eyes were forced to adapt to a landscape of high-contrast synthetic pigments that overwhelmed the softer, organic palettes of our ancestors. We traded the mystery of the rare for the convenience of the replicated. In this shift, the human brain was essentially retrained to recognize a synthetic blueprint of the spectrum. The Industrial Revolution did more than just give us new colors. It reshaped our visual vocabulary, creating a world where the blue we see today is a product of human ingenuity as much as it is a reflection of the light itself. We are living in a landscape designed by chemistry, seeing a world that was manufactured to be seen. And yet, as we mastered the chemistry of the Earth to replicate the colors of our world, we simultaneously turned our gaze upward, seeking to understand the vast, silent theater of the cosmos. For millennia, humanity was limited by the horizon of the naked eye, a perspective that rendered the heavens a static tapestry of distant lights. We saw the stars as mere pinpricks in a velvet void, unable to perceive the staggering depth or the intricate textures of the celestial bodies that governed our nights. We were spectators watching a play from the furthest row, seeing only the finished scenery, but never the machinery behind the curtain. The invention of the telescope shattered this ceiling of perception, creating a technological leap that fundamentally altered the human visual horizon. When the first lenses were polished and pointed toward the stars, the heavens were no longer a flat map, but a three-dimensional cathedral. Suddenly, the empty space between the stars was revealed to be a profound, cavernous abyss. We transitioned from a world of distant points to a universe of immense scale, where the distance between two sparks of light could represent light years of lonely, stretching nothingness. This expansion of our visual reach forced a psychological reckoning. Seeing the infinite in such high detail didn't just provide new data, it provoked a sense of sublime vertigo. It was the first time the human psyche had to grapple with its own insignificance against the backdrop of a truly massive, detailed universe. Beyond just size, the telescope introduced us to the hidden chromatic secrets of deep space. Through these glass portals, we began to witness new colors and phenomena that the human eye simply could not capture from the ground. We saw the swirling, violent hues of nebulae and the ghostly glows of distant galaxies. These were not just colors in the traditional sense, but signatures of energy, heat, and chemistry. We learned to see the universe not as a monochrome dream, but as a vibrant, high-definition reality. Perhaps the most profound shift occurred with the discovery of the blue shift. As our instruments became more sophisticated, we realized that color was not just an aesthetic quality, but a messenger of motion. By observing how light changed frequency as galaxies moved toward or away from us, we discovered that the very color of a galaxy could tell us its velocity and its destiny. The heavens became a moving gallery, where the blue of a receding or approaching object was a literal measurement of the expansion of space itself. The telescope took the heavens out of the realm of mythology and placed them into the realm of physics, transforming the sky from a mysterious ceiling into a dynamic, measurable frontier. We were no longer just looking at the stars. We were reading the history of the universe, one refracted beam of light at a time. But even as our telescopes began to map the vast reaches of the cosmos, a much smaller, more intimate mystery remained hidden within the very architecture of our own biology. If we look past the glass of our lenses and into the microscopic theater of the human eye, we find that our ability to perceive the blue of the heavens is governed by a complex, invisible blueprint written in the language of our own DNA. To understand why some people are born into a world where the blue spectrum is forever silenced, we must descend into the genetic architecture of the human cone cells. Inside our retinas, specialized cells called cones act as the primary sensors of light. They are the gatekeepers of our visual reality, and each type is governed by specific genes. Among these, the OPN1LW and OPN1SW genes are the primary architects of our color experience. The OPN1LW gene is responsible for the long wavelength sensitivity, allowing us to perceive the warmth of reds and oranges. However, It is the OPN1SW gene that serves as the master key for the short wavelength spectrum. It is this specific gene that enables the S-cones to capture the high-frequency vibrations of blue light. When this gene functions perfectly, it allows the brain to distinguish between the deep azure of the ocean and the golden hues of the sun. But what happens when this genetic script is altered? The mystery of tritanopia, the rare condition where the ability to see blue is diminished or lost, lies in the subtle mutations of the OPN1SW gene. Unlike more common forms of color blindness, tritanopia is a whisper in the genetic code. It occurs when a mutation disrupts the production of the specific proteins required for S-cone function. In these individuals, the blue frequency is not merely muted, it is functionally absent. The biological machinery simply fails to tune in to that specific station of the light spectrum. This is not a modern glitch, but a relic of our evolutionary history. Throughout the ages, the human genome has been a laboratory of sensory adaptation. While most of our species evolved to prioritize the detection of reds and greens, likely to distinguish ripe fruit from leafy foliage, or to spot predators against a forest backdrop, the blue spectrum remained a secondary, more specialized frontier. In the vast diversity of color vision across the animal kingdom, some species possess a much more robust ability to perceive ultraviolet, while others are entirely blind to the nuances of the blue-yellow axis. Our own visual experience is a biological lottery, a result of silent mutations that have accumulated over millennia. These are genetic variations that do not necessarily hinder survival, but do fundamentally reshape the subjective experience of the world. For a person with tritanopia, the world is not broken in a conventional sense. It is simply rendered in a different chromatic palette. They are navigating a reality where the blue horizon is replaced by a yellow-tinted shadow, a hidden truth dictated by a few microscopic changes in their genetic sequence. It is a reminder that our perception of reality is never an absolute truth, but a subjective masterpiece painted by the unique instructions of our own cells. But what if the very silence of a color is not a failure of the eye, but a deliberate muting by the brain's internal conductor? To understand this, we must move beyond the genetics of the retina and travel deeper into the labyrinth of the human brain, where the raw data of light is transformed into the poetry of vision. This is where the true mystery of the muted frequency resides, hidden within the complex neurological pathways that dictate our reality. When light enters the eye, it travels along the optic nerve, a high-speed fiber optic cable carrying electrical impulses toward the back of the skull. The first major waypoint in this journey is the lateral geniculate nucleus. Think of this structure as a sophisticated sorting station, a relay center that receives the frantic chatter of visual information and begins to organize it into coherent signals. However, when neurological conditions arise, whether through chronic illness, trauma, or neurodegeneration, this sorting station can become compromised. It is here that the brain may begin to filter certain frequencies, not because the light isn't arriving, but because the brain has lost the ability to prioritize those specific signals. In the landscape of neurodegeneration, the brain undergoes a structural and functional transformation. As neurons wither or connections fray, the brain's ability to maintain a full spectrum of perception begins to erode. This leads to a phenomenon known as the graying out of specific frequencies. It is a chilling biological paradox where the brain, overwhelmed or damaged, effectively turns down the volume on certain wavelengths to preserve the clarity of others. For an individual whose brain is struggling to process the sheer volume of environmental data, the blue frequency, which requires high-frequency processing, might be the first to be sacrificed. The brain, in a desperate act of survival, mutes the blue to keep the rest of the world from becoming a chaotic blur. This brings us to the haunting distinction between structural and functional vision loss. Structural loss is the physical destruction of the hardware, like a broken lens or a severed nerve. Functional loss, however, is far more mysterious. In functional loss, the hardware remains intact, but the software of the brain fails to interpret the code. The optic nerve sends the pulse, the cones have fired, and the lateral geniculate nucleus has received the message, but the visual cortex, the brain's grand gallery, simply chooses not to paint the blue. We are left with a profound neurological mystery. Why does the brain choose to mute specific waves? Why does it select the blue frequency as the one to silence? Some scientists suggest it is a matter of energy conservation, a biological, power-saving mode, where the brain prioritizes the colors most essential for immediate survival. Others believe it is a byproduct of the way our visual cortex is wired to perceive depth and distance. In these neurological conditions, the world doesn't just go dark, it loses its nuance. A piece of the spectrum is stolen away, leaving a ghost of a color where a vibrant blue should be, proving that what we see is not just a reflection of the world outside, but a curated story told by the hidden machinery of the mind. Imagine for a moment that your eyes are not merely windows, but sophisticated chemical laboratories, processing a torrential rain of invisible energy every single second. To understand why some people perceive the world in a muted palette while others see a vibrant explosion of hue, we must journey deep into the microscopic architecture of the retina. Here, in the velvet darkness of the back of the eye, a silent miracle of physics and biology unfolds. At the heart of this journey are the photoreceptors, specifically the 3 types of cones. These are the sentinels of our visual world, each tuned like a delicate musical instrument to a specific frequency of light. Think of them as 3 distinct filters, each responding to a different note in the symphony of the electromagnetic spectrum. We have the L cones, which are sensitive to the long, sweeping wavelengths of red. We have the M cones, which find their rhythm in the medium waves of green. And then there are the S cones, the short wavelength sensors, which are the primary gatekeepers of the blue end of the spectrum. When a photon, a tiny packet of light energy, strikes the surface of the retina, it begins a process known as phototransduction. This is not a simple mechanical click. It is a complex chemical cascade. Within each cone sits a protein called opsin, which holds a molecule called retinol. When a photon strikes this molecule, it causes a physical change in its shape, a microscopic shift that triggers a waterfall of chemical reactions. These chemicals move like a tide, altering the electrical charge of the cone cell. The secret of color lies not in a single cone identifying a single color, but in the beautiful, complex math of ratios. Your brain does not see blue because a blue sensor turned on. Instead, your brain receives a simultaneous signal from all 3 types of cones. When you look at a clear summer sky, the S cones fire with great intensity, while the L and M cones remain relatively quiet. Your brain compares these 3 different levels of electrical activity and performs a rapid, subconscious calculation. It looks at the ratio of the signals and translates that specific mathematical proportion into the subjective experience of blue. This process happens with breathtaking speed, occurring in mere milliseconds. It is a constant, flickering dance of chemistry where light is broken down into a language of electricity. If the S cones are damaged or fail to fire, the ratio is broken. The brain, unable to find the blue signature in the math, may interpret the light as a different hue entirely or lose the distinction altogether. We often believe we see the world as it truly is, but in reality, we are seeing a masterpiece of biological data processing, a secret chemical translation that turns a chaotic storm of photons into the quiet, steady colors of our dreams. But what if the most vital note in this visual symphony were to suddenly fall silent, leaving a hollow space where a color should exist? To understand the experience of a tritanope, we must look at the profound biological silence of the S cone. In a typical eye, the S-cone acts as a high-frequency receiver, catching the shortest waves of the visible spectrum. When these cells fail to fire, they do not simply send a weak signal. They enter a state of chemical dormancy. The opsin proteins within them remain unchanged, and the waterfall of electrical impulses that usually informs the brain of blueness never begins. It is as if a radio station has gone off the air, leaving a void in the broadcast. For the person living with this condition, the world undergoes a subtle yet profound reorganization. This creates a visual dead zone, a specific frequency of reality that becomes effectively invisible. Because the brain relies on the ratio of signals between the L, M, and S cones to construct color, the absence of the S-cone signal causes the mathematical equation of the world to collapse. When light hits the retina that should trigger a blue response, the brain receives only the signals from the long and medium waves. Without the blue component to balance the equation, the brain is forced to interpret the data using a fractured set of rules. This is where the mystery of the human mind truly begins. The brain abhors a vacuum of information. When it encounters a frequency of light it cannot decode through the usual S-cone pathway, it struggles to interpret the missing data. For a tritanope, the sensation is not necessarily one of seeing gray in the way we think of a rainy sidewalk. Rather, it is a sensation of a colorless void, a spectral gap where a primary pillar of the visual experience has been replaced by a phantom hue. They may see a sky that feels different, perhaps leaning toward a yellowish or greenish tint, because the brain is trying to compensate for the missing blue anchor. Imagine trying to hear a chord on a piano where the highest note is permanently muted. You still hear the music, but the shape of the harmony is fundamentally altered. This is the lived experience of the tritanope. It is a world where the distinction between blue and green or yellow and violet becomes blurred or merged. The chemical failure point is not just a lack of sight. It is a reorganization of the entire visual landscape. The brain takes the remaining signals and tries to weave a coherent story out of an incomplete set of threads. In this hidden architecture of the eye, the silence of the S-cone reveals a startling truth about our perception. We do not see the world as it is. We see the world as our biological chemistry allows us to translate it. When one sensor falls silent, the very map of our reality is redrawn, leaving us to wander through a world where the blue horizon has been replaced by a beautiful, strange, and unfamiliar ghost of a color. But what if your mind possesses the uncanny ability to manufacture a reality that does not exist in the physical world? To understand this, we must step away from the chemistry of the retina and enter the complex architecture of the visual cortex, where the brain ceases to be a passive observer and begins to act as a creative storyteller. You see, the human brain is not a camera recording a scene. It is a simulator, a high-speed prediction engine that constantly builds a model of the world to help you navigate it safely. This process is known as predictive processing. In this sophisticated inner theater, the brain is always running a simulation. It doesn't wait for every single photon to arrive before it decides what you are looking at. Instead, it uses your past experiences and memories to guess what the world should look like, only using the incoming data from your eyes to correct those guesses. This is the secret of color constancy. When you see a red apple in the shade, or a blue lake under a harsh midday sun, the object remains the same color in your mind. This is because your brain identifies the light source and subtracts its influence, filling in the gaps with your own internal knowledge of what an apple or a lake is supposed to be. It is a form of controlled inference, a graceful hallucination that allows you to perceive a stable world despite the fact that light is constantly shifting. This brings us to a fascinating neurological impulse known as filling in. Consider the famous blind spot in your field of vision, where the optic nerve attaches to the retina. At this specific point, there are no photoreceptors at all. There is no biological data entering the brain from this tiny patch of space. Yet, when you look at a continuous image, you do not see a black hole or a missing piece of the puzzle. Your brain simply invents the missing information. It looks at the surrounding textures, the colors, and the patterns, and it performs a seamless stitch, weaving the missing data into the fabric of your vision. It is a masterpiece of creative completion, a neurological reflex to maintain the integrity of the scene. We must distinguish this from a true hallucination. A hallucination is an image that appears without any external stimulus or context. What your brain does is an inference. It is a sophisticated guess based on a mountain of prior data. It is the brain's way of smoothing out the noise of the universe. When some people cannot see the color blue, their brains are faced with a profound lack of data in that specific frequency. In response, the brain's predictive engine works overtime. It attempts to complete the pattern of the world using the remaining colors available to it. It creates a phantom, a synthetic substitute, trying to maintain a coherent narrative of reality. It is a beautiful, desperate act of biological imagination, proving that the world you see is not just a reflection of the light outside, but a construction built within the sanctuary of your own mind. And yet, if the brain is a master storyteller, we must ask ourselves how it manages to translate the chaotic, invisible fire of electricity into the coherent, vivid imagery of our dreams. To find the answer, we must follow the journey of a single spark as it travels from the back of the eye into the deepest corridors of the mind. Once the retina has completed its chemical dance, the information is no longer a color or a shape. It has been stripped down into a series of rapid-fire electrical pulses known as action potentials. These are the whispers of the nervous system, tiny bursts of voltage that race along the fibers of the optic nerve like lightning traveling down a copper wire. This is the great conversion, the moment where the physical world of light is sacrificed to become the digital world of the brain. But the optic nerve does not send everything it sees. The retina acts as a sophisticated gatekeeper, performing a massive compression of data. It filters out the redundant noise of the environment, discarding the unnecessary details of a static background so that only the most vital changes in light intensity and movement are passed forward. This ensures that the brain is not overwhelmed by a deluge of useless information, allowing the visual system to operate with a speed that defies human comprehension. As these electrical impulses exit the eye, they enter a high-speed transit. The signals travel along the optic nerve, moving with a velocity that ensures the world feels instantaneous rather than delayed. These pulses arrive at a hidden junction known as the thalamus. Think of the thalamus as the grand switchboard of the human consciousness. It is here that the raw data is sorted, prioritized, and routed. It acts as a relay station, deciding which visual signals deserve the brain's immediate attention and which can be relegated to the subconscious. It is the first step in the assembly of a coherent image, a filtering process that prepares the electrical storm for its final destination. The journey concludes in the occipital lobe, the very back of your skull. This is the ultimate workshop of perception. Here, the scattered electrical pulses are finally assembled into a unified mosaic. In this dark, hidden chamber, the brain takes the compressed data, the sorted signals, and the predicted textures, and weaves them into the tapestry of your vision. It is here that the electricity finally becomes a sunset, a face, or a horizon. It is the final transformation where the invisible pulses of the optic nerve are rendered into the visible miracle of our reality. We do not see with our eyes. We see with the symphony of electricity that your brain composes in the silence of your skull. But what if your mind possesses the uncanny ability to manufacture a reality that does not exist in the physical world? To understand this, we must step away from the chemistry of the retina and enter the complex architecture of the visual cortex, where the brain ceases to be a passive observer and begins to act as a creative storyteller. You see, the human brain is not a camera recording a scene. It is a simulator, a high-speed prediction engine that constantly builds a model of the world to help you navigate it safely. This process is known as predictive processing. In this sophisticated inner theater, the brain is always running a simulation. It does not wait for every single photon to arrive before it decides what you are looking at. Instead, it uses your past experiences and memories to guess what the world should look like, only using the incoming data from your eyes to correct those guesses. This is the secret of color constancy. When you see a red apple in the shade, or a blue lake under a harsh midday sun, the object remains the same color in your mind. This is because your brain identifies the light source and subtracts its influence, filling in the gaps with your own internal knowledge of what an apple or a lake is supposed to be. It is a form of controlled inference, a graceful hallucination that allows you to perceive a stable world despite the fact that light is constantly shifting. This brings us to a fascinating neurological impulse known as filling in. Consider the famous blind spot in your field of vision, where the optic nerve attaches to the retina. At this specific point, there are no photoreceptors at all. There is no biological data entering the brain from this tiny patch of space. Yet, when you look at a continuous image, you do not see a black hole or a missing piece of the puzzle. Your brain simply invents the missing information. It looks at the surrounding textures, the colors, and the patterns, and it performs a seamless stitch, weaving the missing data into the fabric of your vision. It is a masterpiece of creative completion, a neurological reflex to maintain the integrity of the scene. We must distinguish this from a true hallucination. A hallucination is an image that appears without any external stimulus or context. What your brain does is an inference. It is a sophisticated guess based on a mountain of prior data. It is the brain's way of smoothing out the noise of the universe. When some people cannot see the color blue, their brains are faced with a profound lack of data in that specific frequency. In response, the brain's predictive engine works overtime. It attempts to complete the pattern of the world using the remaining colors available to it. It creates a phantom, a synthetic substitute, trying to maintain a coherent narrative of reality. It is a beautiful, desperate act of biological imagination, proving that the world you see is not just a reflection of the light outside, but a construction built within the sanctuary of your own mind. And yet, if our brains are capable of weaving such elaborate tapestries of fiction to fill the gaps in our vision, we must wonder if we are merely missing a piece of the puzzle, or if we are trapped within a cage of our own biological making. We often speak of the visible spectrum as the totality of reality, yet it is nothing more than a narrow sliver of a much vaster, hidden ocean of energy. Beyond the violet hues of our conscious experience lies a realm of radiation that our eyes are fundamentally deaf to, a world of heat and vibration known as the infrared spectrum. To understand this, we must recognize the biological limitations of our skin and eyes. Our eyes are tuned to a very specific frequency of vibration, a middle ground that allowed our ancestors to distinguish ripe fruit from green leaves and to navigate the shadows of the forest. However, this specialization comes at a cost. We are effectively blind to the infrared light that radiates from every living thing. While we see a cold, gray stone, the universe is actually humming with thermal energy that passes through our retinas like a ghost through a wall. We are living in a sensory desert, surrounded by a vibrant, invisible fire that we lack the hardware to perceive. Consider the majestic snake, a creature that breaks the rules of our visual cage. Some species possess the ability to sense infrared radiation, effectively seeing the heat signatures of their prey. To them, the world is not just a collection of colors, but a glowing map of metabolic activity. They see the warmth of a heartbeat and the heat of a hidden nest. This is the ultimate form of sensory expansion, a biological upgrade that allows a creature to peel back the veil of the visible world. They possess a truth about the environment that remains perpetually hidden from us, a secret dimension of heat that we can only approximate through technology. In our quest to overcome these limits, we have built our own mechanical eyes. Infrared cameras do not see color in the traditional sense. They translate the invisible heat of the universe into a visual language we can finally comprehend. They allow us to see the invisible breath of a human, the lingering warmth of a footprint, and the silent radiation of the stars. These technologies are our attempts to break out of the human visual cage, to reach past the biological walls our evolution built around our consciousness. We are explorers standing on the shore of a vast, invisible sea, peering out at a horizon we cannot see. Our perception is a sanctuary, yes, but it is also a fortress that keeps the rest of the spectrum at bay. When we speak of what is real, we must remember that our reality is defined by what our chemistry allows us to notice. Beyond our blue horizons and our green forests lies a world of heat, of radiation, and of frequencies that remain forever silent in the symphony of the human mind. We see only the spark, while the rest of the fire remains a mystery. Imagine walking through a world where the very concept of the horizon has been erased from your mind. Close your eyes and try to visualize a vast, open ocean or the deepest reaches of a midnight sky. Now, imagine those spaces are not a vibrant, deep azure, but instead a muted, heavy gray or a dull, dusty ochre. This is the reality for those whose neurological pathways do not recognize the frequency of blue. It is not merely a missing color. It is a fundamental shift in the architecture of human perception. When the blue spectrum is removed, the first thing to vanish is the sensation of infinite depth. In our visual world, blue serves as the ultimate shorthand for distance. It is the color of the atmosphere, the receding tide, and the far-off mountain range. Without it, the world can feel strangely flattened. The psychological blindness to these environmental cues creates a visual landscape that feels more intimate and perhaps more claustrophobic. The vastness of the world is replaced by a series of immediate, textured surfaces. The eye no longer finds rest in the distance because the distance has lost its signature hue. Consider the emotional weight of the color blue. We often associate it with serenity, with the stillness of a lake or the cooling shadows of twilight. It is a psychological anchor for calm. For someone without this perception, that specific emotional trigger is absent. They do not experience the quiet of blue. Instead, their internal emotional map must recalibrate. They may find peace in the earthy greens of the forest or the warm golds of a setting sun, but the unique, melancholic peace of the blue hour remains a phantom sensation, a ghost of a feeling they can hear about but never hear themselves. This leads us to a fascinating shift in aesthetic preferences. When a primary component of the visual palette is missing, the brain becomes hyper-attuned to the remaining frequencies. The nuances of violet and teal begin to bleed into one another, creating a unique visual tapestry where the boundaries between colors are blurred and redefined. It is a private, isolated visual reality. They are navigating a world that feels like a masterpiece painted with a restricted palette, where every other color must work twice as hard to convey the complexity of the environment. Scientists have studied color-deprived environments to understand how the human psyche adapts. They have discovered that the brain is remarkably resilient. When a color is muted, the visual cortex performs a complex feat of compensation. It fills in the gaps, attempting to construct a coherent world out of incomplete data. It is a mystery of the mind, how we can perceive a complete reality when our biological hardware is missing a piece of the puzzle. They are living in a world of hidden secrets, where the most expansive color in our shared experience is, for them, a silent, invisible void. It is a journey into a different kind of light, a quiet voyage through a world where the sky is a mystery they can sense, but never truly see. But what if the very color we associate with peace and tranquility is actually viewed by some as the chilling herald of the end? While the modern world often paints blue as a symbol of serenity, a journey through human history reveals a much darker, more complex spiritual map. For many cultures across the globe, blue is not a sanctuary of calm, but a doorway to the unknown, a hue that signals the transition from the warmth of the living to the frost of the afterlife. To understand this, we must look at the physical sensations of the color. Blue is inherently cold. It is the color of ice, the numbing chill of a winter morning, and the leaching of heat from the skin. In many spiritual traditions, death is described as a state of profound cold, a withdrawal of the vital spark of life. When a culture associates blue with the beyond, they are mapping the physical sensation of dying onto a visual frequency. It is the visual representation of the hushing of the soul. This connection is often anchored in our primal relationship with water. For those living near the coast or deep within the interior of continents, water is both a source of life and a source of sudden, terrifying death. The vast, undulating surface of the ocean can be a beautiful cradle, but it can also be a tomb. In many regions, the deep, bottomless blue of the sea is synonymous with drowning, a silent and watery erasure of the self. When we see a deep blue, our subconscious may be tapping into these ancestral fears of being pulled under, of losing our breath, and of merging with a liquid void that offers no oxygen, only stillness. In these cultures, the symbolism of color becomes a stark binary. If blue represents the cold, receding tide of death, then colors like red and green become the vibrant screams of survival. Red is the pulse, the blood, the heat of the hearth, and the frantic energy of the hunt. Green is the burgeoning leaf, the growth of the harvest, and the lush fertility of the earth. To these societies, blue is the ultimate other, a color that exists outside the circle of life. It is the color of the horizon that we cannot cross, the shadow that lingers where the light has failed. There is a profound mystery in the blue void. It is the color of the atmosphere, but it is also the color of the empty space between stars. It is the color of the nothingness that humans have feared since the first time we looked up and realized how small we were. In mourning rituals, the use of blue serves as a somber acknowledgement of this emptiness. It is a way of honoring the departed by surrounding them with the color of the distance, a visual sigh that marks the moment a person moves from the vibrant reds of the present into the quiet, blue shadows of history. It is a haunting paradox, where the most expansive color in our sky becomes the most intimate color of our final rest. But what if the very limits of your vision are not set by your eyes, but by the way your brain chooses to surrender to the world around you? To understand this, we must step into the sterile, controlled atmosphere of a laboratory where the boundaries of human perception were pushed to their breaking point in what became known as the Blue Room experiments. In these studies, researchers sought to understand the profound plasticity of the human visual cortex by placing subjects in environments saturated with a single, monochromatic hue. Imagine being placed inside a space where every wall, every floor, and every object is bathed in an unrelenting, unwavering blue. In a world of constant stimulus, the brain faces a startling challenge. Our visual system is designed to detect contrast, to find the difference between a leaf and a stone, or a shadow and a highlight. When that contrast is removed and replaced by a singular, overwhelming frequency, the brain begins to experience a phenomenon known as sensory adaptation. It is a form of neurological fatigue, where the neurons responsible for processing that specific wavelength begin to tire, eventually becoming less responsive to the input. As the hours turn into days, a strange and haunting transformation occurs within the observer's mind. The brain, desperate to find meaning in a landscape of sameness, starts to downregulate its response to the blue light. This is the process of recalibration. The brain essentially decides that since the blue is nothing in terms of change, it is nothing in terms of importance. In the blue room, the color that was once vibrant and piercing begins to fade into a ghostly, neutral gray. The vivid azure of the room bleeds into a dull, washed-out haze, proving that our perception of color is not a static truth, but a fluid negotiation between the eye and the mind. This experiment revealed a hidden secret about our sensory limits. We do not see the world as it is, we see the world as it differs from what we just saw. When the brain is starved of variety, it begins to mute the dominant frequency to protect itself from sensory overload. This is a form of psychological fatigue, where the sheer weight of a constant color creates a mental heaviness, a sense of being submerged in a thick, chromatic soup. It challenges the myth that our vision is a perfect recording of reality. Instead, it shows that our brains are masters of efficiency, willing to sacrifice the nuance of a primary color just to maintain a sense of balance. Ultimately, the Blue Room experiments showed us that our perception is a fragile construction. By isolating a single hue, scientists discovered how the human psyche can be forced to remap its entire visual vocabulary. It proved that the blue we see today is only visible because it is surrounded by other things. In a world of only blue, blue eventually disappears, leaving the observer in a silent, monochrome void where the brain has finally traded the vibrant spectrum for a muted, exhausted piece. And yet, we must ask ourselves if the absence of a color is merely a visual deficit, or if it fundamentally rewires the very architecture of the human soul. When a primary color like blue is missing from a person's perceptual reality, the psyche undergoes a profound internal restructuring, moving beyond simple color blindness into a state of fragmented existence. It is a mystery of the mind how the loss of a single frequency can alter the way one navigates the vastness of the world. For those who cannot see blue, the concept of the infinite, that staggering sense of distance and scale, becomes structurally different. Blue is the visual shorthand for the receding horizon, the atmospheric haze, and the deep reaches of the unknown. Without it, the world can feel strangely compressed, as if the great expanses of the earth have been pulled closer, stripping away the breathable space between the observer and the distance. This creates a fascinating psychological divergence between seeing a color and truly experiencing it. One can be told that the sky is blue, and one can understand the word, but the subjective experience of that specific vibration is a phantom limb of the senses. The brain, faced with this missing data, performs a remarkable feat of neurological compensation. It begins to fill in the gaps, creating a subjective sense of a world that is fundamentally incomplete. It is a form of visual mourning for a part of the spectrum that exists in the physical world, but has been exiled from the personal one. The psyche must learn to interpret a world where the quiet of the blue hour is replaced by a different, perhaps more tactile, form of stillness. Furthermore, this missing data forces a narrowing of the emotional palette. Colors are not just light waves, they are emotional anchors. If the serene, cooling frequency of blue is absent, the mind must find its equilibrium in other hues, perhaps leaning into the grounded stability of earth tones or the vibrant urgency of reds. It is a private, isolated reality where the boundaries of the remaining colors must expand to fill the void. The brain becomes hyperattuned to the nuances of teal and violet, stretching these frequencies to carry the emotional weight that blue usually bears alone. Philosophically, this suggests that our reality is not a shared objective truth, but a series of subjective filters. If two people can look at the same ocean and one sees a vast blue void while the other sees a muted gray, they are effectively living in different universes. It challenges the very notion of a unified human experience. The missing color becomes a silent secret, a hidden wall in the architecture of the mind. It reveals that our perception is not a mirror of the world, but a construction of what the brain chooses to keep, what it chooses to discard, and how it heals the fractures of a fragmented visual reality. But what if the very horizon you see is not a physical line, but a psychological surrender to the concept of the infinite? To understand why our perception of forever is so inextricably tied to the blue of the distance, we must look at the ancient alchemy of atmospheric perspective. In the world of optics, there is a phenomenon where the atmosphere scatters shorter wavelengths of light, causing distant objects to lose their sharp edges and their true colors. This is why mountains appear hazy and why the furthest reaches of the ocean seem to dissolve into a pale, ethereal wash. For the human brain, this bluing of the distance is the primary visual cue for scale. It is the biological shorthand that tells us something is far away, beyond our immediate reach, and potentially limitless. When we look at a blue horizon, we are not just seeing a color. We are witnessing a visual surrogate for the unknown. Evolutionarily, this has served as a vital survival mechanism. By associating blue with vast, receding spaces, our ancestors could distinguish between the immediate dangers of the forest floor and the safety, or the mystery, of the open expanse. The blue horizon acts as a gateway, a visual boundary that suggests there is always more beyond what the eye can currently capture. It is the color of elsewhere. It is the visual representation of and then, the perpetual continuation of space that keeps the human mind from feeling trapped by its own immediate surroundings. Yet, there is a haunting paradox in this connection. While blue provides the sense of infinite space, it simultaneously evokes a profound sense of awe and primal fear. This is the sublime of the natural world. The vast, blue expanse of the ocean or the towering blue of the atmosphere reminds us of our own fragility. It is a color that suggests a scale so large it can swallow the individual whole. This is why, for many, the blue horizon feels like a threshold between the known and the unknowable. It is a psychological mirror of the human condition, a constant reaching toward a horizon that recedes as quickly as we approach it. For those who cannot perceive this specific frequency, the architecture of the infinite undergoes a startling transformation. Without the blue haze to signal distance, the world may lose its sense of depth, becoming a series of immediate, textured surfaces. The forever of the horizon is replaced by a more intimate, perhaps more claustrophobic, reality. The sense of the infinite is not gone, but it is no longer painted in the signature hue of the atmosphere. It becomes a phantom distance, a concept understood through the logic of the mind rather than the testimony of the eye. In this way, the blue horizon is more than a visual fact. It is the way our species has learned to dream of the unreachable, a chromatic bridge between the solid ground beneath our feet and the terrifying, beautiful vastness of everything we have yet to see. And yet, we must wonder, what secrets does the blue void hold for modern neuroscientists as they peel back the layers of our internal reality? We are currently standing at the precipice of a revolution in sensory science, moving beyond the simple mechanics of the eye to the complex architecture of the mind. In high-tech neurological labs, the study of tritanopia is no longer a mere footnote in medical textbooks. Researchers are diving deep into how the brain processes the short wavelengths, attempting to map the specific neural pathways that handle the blue-yellow axis. They are looking for the why behind the how, seeking to understand why the brain might choose to prune or ignore certain frequencies during the formative years of visual development. This journey leads us into the mysterious territory of the dark end of the spectrum. Neuroscientists are increasingly fascinated by the limits of human visibility, exploring how our brains interpret the threshold where light turns into shadow. They are investigating the forbidden colors, those impossible hues that the human eye cannot physically perceive, but the brain desperately tries to construct. These are the visual glitches in our perception, the colors that exist in the math of physics but remain locked away from our conscious experience. By studying these gaps, scientists hope to uncover the ultimate blueprint of how we construct our visual world, discovering that what we see is often just a highly edited summary of a much more complex, hidden reality. The frontier of this research is pushing toward the future of visual enhancement technologies. We are approaching an era where we might be able to unlock the spectrum, using neural interfaces or advanced optics to feed the brain data it was never evolved to receive. Imagine a world where we could perceive the infrared heat of a living body or the ultraviolet patterns of a flower, effectively expanding the bandwidth of human consciousness. This is the ultimate goal of modern sensory exploration: to turn the blue void from a mystery of missing data into a gateway for expanded perception. But even as we look forward, we are haunted by the fundamental mysteries of the visual cortex. Scientists are still struggling to understand the filling-in phenomenon, where the brain creates a seamless reality by guessing what lies in our blind spots or beyond our sensory reach. It suggests that our entire visual life is a magnificent hallucination, a coherent story told by the brain to keep us from seeing the fractured, incomplete data of the raw universe. The blue void is the ultimate laboratory for this study. It represents the point where biology meets imagination, where the brain decides what is important enough to be seen and what is destined to remain in the shadows of the unknown. We are beginning to realize that the secret of the blue void is not just about a missing color, but about the very way the human mind weaves together the threads of light to create the tapestry of our existence. Imagine standing in a vast, silent field where the horizon melts into the sky, and suddenly realizing that the very color you are looking at might be a phantom of the mind. Why is it that among all the vibrant hues of our world, blue remains the most elusive, the most ghost-like, and the most structurally mysterious of all human experiences? To understand this, we must journey back into the very fabric of our existence, peeling back the layers of biology, geology, and ancient history to see why blue feels less like a color and more like a secret. Consider first the physical world. For millions of years, the Earth was a palette of browns, ochres, and deep reds. Blue is a geological outlier. It is rarely found in the organic matter of our immediate surroundings. Unlike the pigment of a berry or the rust of iron, true blue is often a mineral rarity or a trick of the atmosphere. Because it was so scarce in the physical landscape, our ancestors had to work harder to define it. It was not a color you could simply pick up from the ground. It was something you had to capture from the air or the deep water, making it an abstract concept before it was ever a physical reality. This scarcity created a profound linguistic delay. In many ancient cultures, the word for blue simply did not exist. They saw the sky and the ocean, but they lacked the internal framework to categorize them as a singular hue. To them, the heavens were a state of being, a spiritual realm, rather than a specific wavelength of light. This is the great paradox of blue. It is simultaneously everywhere and nowhere. It is the most omnipresent color in our atmosphere, yet it was one of the last colors to be named by the human tongue. Then we must look at the biological gatekeepers. Our eyes are filters, and the way we process the short wavelength end of the spectrum is a delicate evolutionary dance. For some, the blue frequency is a whisper that the brain struggles to hear. When the S-cones, the specialized cells responsible for detecting blue, fail to fire or are suppressed by neurological noise, the world loses its depth. The unreachability of true blue becomes a physical wall. For those who cannot see it, the world is rendered in a different, perhaps more grounded reality. They live in a world of warmth and earth, while we live in a world of shadow and mist. Blue holds a spiritual weight because it represents the infinite. It is the color of the distance we can never touch. It is the ultimate visual mystery because it occupies the space between what is known and what is felt. We are haunted by the blue void, a hue that suggests a depth that goes on forever. It challenges our senses because it is a color of transition. It is the ghost of the horizon, the sigh of the atmosphere, and the silent frequency that remains just out of reach for so many, reminding us that our perception of reality is only a small window into a much larger, more mysterious spectrum of light. But if our eyes are the windows to our world, we must ask ourselves if those windows are designed to show us the truth or merely to show us what we need to survive. You see, the reality you perceive every moment is not an objective masterpiece of the universe. It is a curated selection, a biological edit of the light that dances around you. Our ancestors did not evolve to see the most beautiful colors, they evolved to see the most useful ones. Think of your vision as a masterpiece of biological censorship. The universe is flooded with a staggering array of radiation, from the searing heat of infrared to the piercing energy of ultraviolet. Yet, to the human eye, these frequencies are invisible. This is not a failure of our anatomy, but a deliberate triumph of evolution. If we could perceive the full breadth of the electromagnetic spectrum, our brains would be overwhelmed by a chaotic blizzard of data. We would be blinded by the heat of a nearby fire or the invisible radiation of the sun. Instead, nature has placed a gatekeeper at the door of our consciousness, filtering out the useless and highlighting the vital. This curation involves a delicate trade-off between sensitivity and resolution. Evolution decided that for a primate to survive, it was more important to distinguish between a ripe fruit and a poisonous leaf than it was to see the complex nuances of the ultraviolet bloom. Our eyes became specialized instruments, tuned to a narrow band of light that provides the maximum amount of information for the minimum amount of energy. We are living in a human-centric reality, a sheltered gallery where the walls are painted with the colors of survival. This means that everything you see, the deep velvet of a shadow, the vibrant gold of a leaf, the ghost of a blue horizon, is a biological compromise. Our eyes have discarded the noise of the infrared and the danger of the ultraviolet to create a stable, navigable world. We are, in a sense, living in a sensory cocoon. When we look at the world, we aren't seeing the raw data of the universe. We are seeing a polished, edited version of it. For some, this curation is even more restrictive. When a person cannot see blue, it is a poignant reminder that our universal reality is actually a fragile consensus. Their experience of the world is a different curation entirely, a version of reality where the gatekeeper has closed one specific door. It forces us to confront a startling truth. If our evolution can dictate what we are allowed to see, then our perception of truth is merely a matter of biological permission. We do not see the world as it is, we see the world as our ancestors needed it to be. We are voyagers on a ship, looking through a porthole that has been shaped by millions of years of necessity, forever wondering what lies beyond the frame of our own design. But if our perception is a biological edit, we must confront a deeper, more unsettling mystery about the very nature of your consciousness. Is it possible that you are not actually seeing the color blue at all, but are instead merely recognizing a label your brain has assigned to a ghost? To understand this, we must step away from the retina and journey into the silent, complex architecture of the human mind, where raw sensory data is transformed into the architecture of thought. There is a profound cognitive gap between the raw, chaotic input of the universe and the structured concept of a color. When light hits your eye, it is nothing more than a sequence of electromagnetic waves, a physical vibration of energy. At this stage, there is no blue. There is only a stimulus, a flickering signal that travels along the optic nerve like a spark of electricity. It is a biological detection, a mere chemical reaction in the cells of your vision. However, the moment that signal reaches the higher reaches of your brain, the transformation begins. This is where the prefrontal cortex enters the story. This region of the brain acts as the librarian of your internal world, taking that raw, nameless flicker of light and filing it into a folder. It is here that the word blue is born. When you look at the sky, your eye detects a specific wavelength, but your brain provides the knowing. You are not just perceiving a frequency, you are constructing a concept. You are layering history, language, and cultural recognition over a physical fact. Think of it as a mental sculpture. The light provides the clay, but your mind provides the form. In ancient civilizations, this construction was vastly different. Because they lacked the linguistic labels for blue, they might have perceived the same wavelength as a spiritual presence or a divine void, rather than a color. They saw the data, but they knew it through a different cultural lens. They were looking at the same truth, but their internal blueprints were drawn with different lines. We often mistake our subjective experience for objective reality. We believe we are seeing the truth of the blue horizon, but in reality, we are seeing a mental map. The wavelength is an objective fact of physics, but blue is a subjective construction of human knowledge. It is a piece of software running on the hardware of your nervous system. When you see blue, you are witnessing a collaboration between the universe and your own biography. You are not just an observer of the world, you are a co-creator of it. Every color you perceive is a bridge built between the outside world and your internal library of symbols. The mystery of blue, therefore, is not just about why some people cannot see it. It is about the realization that what we all call reality is actually a beautifully curated hallucination, a masterpiece of cognitive construction where the act of seeing is merely the first step, and the act of knowing is where the true story begins. And yet, this leads us to a haunting question. Why does the brain insist on creating a blueprint for colors that, for some, do not exist at all? To understand this, we must peer into the most profound mystery of our neurological architecture, the way the mind seeks to repair the void and complete a fractured masterpiece. When the eyes fail to deliver a specific frequency, such as the elusive blue, the brain does not simply accept a blank space. Instead, it engages in a process of predictive modeling, an internal architect desperately trying to build a complete house even when some of the bricks are missing. Imagine the brain as a tireless artist, one who hates a vacuum. It is constantly scanning the world, anticipating what should be there based on the surrounding data. When a person with tritanopia looks at a horizon, the physical input for blue is absent, but the brain recognizes the context of the scene. It sees the surrounding yellows and greens, the depth of the shadows, and the gradient of the atmosphere. Because the mind demands a coherent narrative, it begins to fill in the missing piece. It constructs a synthetic vision, a mental placeholder that mimics the logic of a complete spectrum. It is a neurological desire for wholeness, a drive to ensure that the world feels continuous rather than fragmented. This process reveals the hidden distinction between true vision and synthetic vision. True vision is the raw, honest data of the external world, but synthetic vision is the brain's creative interpretation of that data. When the brain creates a blueprint for the unseen, it is performing a feat of imagination. It uses the surrounding textures and colors to guess what the missing blue should feel like. It creates a ghost of a color, a phantom sensation that allows the observer to navigate a world that is technically incomplete. It is as if the mind is whispering a story to the eyes, saying, "I know this is here, even if you cannot feel it." This is the ultimate revelation of the human brain. It is not a passive camera, but a proactive storyteller. It is a machine designed to manufacture a reality that is usable, even if it is not entirely accurate. The blueprint of the unseen is a testament to our biological necessity for order. We cannot live in a world of holes and gaps. We require a seamless tapestry of experience. By constructing these mental maps, the brain allows us to perceive a world that is more complete than the one our eyes actually receive. We are walking through a gallery where the brain has painted over the cracks in the floor, ensuring that we never have to stumble over the edges of our own limitations. In the end, the blue that many see is not just a wavelength of light, but a triumph of the mind's ability to dream a world into being, creating a bridge across the void of the invisible. And yet, if the brain is currently an artist painting over the gaps in our vision, we must ask ourselves, what happens when we decide to stop painting over the cracks and start redesigning the canvas entirely? We are approaching a pivotal threshold in human history where the boundary between biological evolution and technological intervention begins to blur. For millions of years, our sensory experience has been dictated by the slow, grinding gears of natural selection, but we are now entering an era where we might finally hold the brush ourselves. Imagine a future where the limitations of the human eye are no longer seen as fixed laws of nature, but as engineering challenges waiting to be solved. We are standing on the precipice of human-engineered vision, a transition from being passive observers of a curated spectrum to becoming active architects of our own perception. The next leap in our sensory evolution may not happen through the slow mutation of DNA, but through the integration of bionic systems. We are already seeing the first flickers of this change in the development of advanced ocular implants and neural interfaces that aim to restore sight, but the true revolution lies beyond mere repair. It lies in the expansion of the human palate. In this coming age, we might transcend the narrow window of visible light that has defined our species since we first walked the earth. Imagine the ability to perceive the ultraviolet world, where flowers possess hidden patterns and the atmosphere hums with a different kind of energy. Or consider the profound shift that would occur if we could see into the infrared, perceiving the literal heat of life as a glowing, radiant map. By integrating technology directly into our visual cortex, we could effectively unlock frequencies of reality that have been hidden from us since the dawn of time. This is the transition from biological sight to technological vision. It is the moment we move from the sensory cocoon of our ancestors into a wider, more expansive horizon of perception. We are no longer bound by the scones or the limitations of our genetic code. Instead, we are developing the tools to perceive the invisible, to see the data of the universe in its raw, unfiltered state. This does not mean we will lose our humanity. Rather, it means we will broaden the very definition of what it means to be human. As we merge our biology with our inventions, we move toward a new horizon of perception where the blue mystery is no longer a secret of the atmosphere, but a baseline of a much larger, more vibrant tapestry. We are evolving from a species that sees a small slice of the truth into one that can choose which parts of the universe to illuminate. The future of sensory evolution is not just about seeing better. It is about seeing more. It is about breaking the seals of our biological inheritance and stepping into a world where the only limit to what we can perceive is the scope of our own imagination. But if we are destined to eventually unlock the gates of the invisible, we must first find peace in the sanctuary of the current moment, acknowledging the profound mystery of the light we already hold. We have journeyed through the history of pigments, the architecture of the eye, and the creative whispers of the brain, arriving at a final, quiet revelation about the spectrum's hidden end. The ultimate truth is that our reality is a beautifully shared hallucination. Every color you see, from the deepest velvet of a midnight shadow to the most elusive ghost of a blue horizon, is a collaborative masterpiece between the universe and your own consciousness. It is a gift of perception, a curated experience that allows us to navigate a world that would otherwise be a chaotic, overwhelming blizzard of raw data. There is a deep, meditative beauty in the parts of our world that remain invisible to us. We must realize that just because a frequency is not captured by our biological filters does not mean it lacks significance. The infrared heat of the Earth and the ultraviolet secrets of the flora are still there, vibrating in the silence of the electromagnetic void. They are the hidden threads of a much larger tapestry, weaving a reality that exists beyond the frame of our current design. We are not missing out on the truth. We are simply experiencing a specific, elegant chapter of it. In the blue void, there is a profound sense of peace. It is the space where the physical world meets the infinite. When we contemplate the fact that our eyes only show us what we need to survive, we find a sense of humility. We are voyagers on a ship, looking through a porthole that has been shaped by millions of years of necessity. This realization does not diminish our experience, it sanctifies it. It reminds us that every moment of sight is an act of grace, a biological miracle that translates the raw energy of the stars into a sanctuary of color. As we reach the end of this journey, let us rest in the silence of the spectrum. Let the mysteries of the invisible and the complexities of the blue mystery fade into the background of your mind. You do not need to solve the final secret of light to find rest. The world is wide, the light is vast, and your perception is a miracle of evolution. The secrets of the spectrum are held in the quiet spaces between your thoughts, waiting for the next time you open your eyes to the dawn. Now, let the colors of the day dissolve into the soft shadows of the night. Let the heavy weight of knowing yield to the lightness of being. You are safe in the sanctuary of the present, wrapped in the quiet hum of a universe that is far larger and more mysterious than words can ever capture. Close your eyes now, and let the tapestry of the world fold into the peaceful stillness of sleep. Good night.